Okay, continuing on. Notice that y equals 2 to the x has a y-intercept at 1, right there, and its inverse has an x-intercept at 1. Well, that just came from 0, 1 became 1, 0, that quickly. Introducing the logarithmic function. Well, the truth is we've already introduced it. The logarithmic function is the inverse of the exponential function. But anyways, we'll give it some more sentences here, some more thought. Recall that the inverse of a function is a rule that undoes or reverses the effect of a function. It does the opposite, undoes what's already been done. And now with the exponential function y equals 2 to the x, the input is the exponent and the output is the base 2 raised to that exponent. So the input is x, so I put in a number here, and the output is whatever you get when you go 2 to the power of the number you put in there. Now, we know that the inverse y equals 2 to the x has the equation x equals 2 to the y. Well, there's the exchanging x and y algebraically that we're talking about. Y, right here, becomes x right there, and x becomes y. So there's, if you wanted to say, what's the algebraic inverse of y equals 2 to the x? There it is, x equals 2 to the y. Now, all along when we did inverses, we said, okay, that's fine, reverse x and y, but then resolve for y. We want these things y equals. Well, that's going to be a little more difficult here. We don't have a good way to undo 2 to the power of y. That is, you might be thinking square root, but it's not. It's not x squared. Like, we're not talking about a squared here. We're talking about 2 to the power of. We've very carefully avoided this question most of the way in your math careers so far. We don't ask the question when there's an unknown exponent. It came up at the odd time in grade 11, but really it all came down to trial and error. So now, we're now face to face with it. We want to deal with this situation because it's the one function kind of left that we haven't done the inverse of. Well, for x equals 2 to the y, we can write this as the logarithmic function y equals log 2x. So just like x squared can be flipped over to the other side with square root, that's the way this works. Y equals log 2x. So 2 to the power of over here becomes log 2x. So y is the power you put on 2 to get x. Y is the power you put on 2 to get x. Boy, the first time you hear that, that is big trouble. I understand completely. But let's move along, and it will come along. So some important points. The expression y equals log ax means the exponent that must be applied to base a to obtain the value x. Okay, that's like the most important thing so far. If you want to be able to handle these situations, just start using that sentence right there. Whenever you see log and then a number here and a number there, just say the power I put on a to get x, or whatever those numbers are. And I'm going to hear me say that a few more times in this lesson, and that really is a key point to understanding what's going on. You're looking for an exponent here. You're looking for the exponent you put on a to get x. I don't want to talk too much just about this just yet. Maybe I've beaten it to death already, and we'll get, as we move along, you'll see a little more what I mean. So for a function y equals a to the x, the equation x equals a to the y is called the exponential form of the inverse, and the equation y equals log ax is called the logarithmic form. So you can write this equation the same way. You can write it as x equals a to the y, or you can write it as y equals log ax. Those two things mean exactly the same thing. So let me just hook those two things up. These two things right there mean exactly the same.